Okay, thanks for joining us for this webinar. The webinar is related to the new functionality in Studio OP version 2. Um, I thought that it's very good that we give you a taste of the new functionality in Studio OP. We had similar functionality before in 5D Planner, but now we have a very advanced and very useful application and functionality in Studio OP. Uh, Before I talk about the mining block creation, I would like to just give you an introduction of Studio OP for people that are familiar with our old ISTS functionality in Studio OP in Studio 3 system. We could generate a schedule. In this screen, as you see, we have some mining blocks in a couple of benches in a pit with some roads to different destinations. For example, we have a dump and plant, leach pad, and a stockpile. In in the new Studio OP, this functionality is called schedule. The minimum requirement for any scheduling is mining blocks. As you know, in long-term scheduling, the mining blocks is basically a pattern cell in 3D geological block model, but in scheduling or schedule functionality in Studio OP, the mining blocks is basically a bigger block in a bench or in a pushback, and the size of this mining block is really related to the different factors, but probably the main factor is the ore production and the total rock movement in a mine. The The maximum size of one mining block can be one bench of a pushback, and as you all know, the minimum size of a pushback can be, a mining block can be a blast outline or blast in short-term scheduling. In our old ISTS, probably we didn't have any functionality to create these mining blocks. When I say these mining blocks, if you look at this screen, when I select any of these units, I call this one mining unit or mining outline, or let's call it mining block. As soon as I click on any of this block, the reserve in this block is shown in the reserve window. And as I said, this is the minimum requirement for scheduling. But what is the connection between this mining block and this reserve file? Let's look at the file first. If I look at the mining block as a string file, there is one field in this file which is very important, and that field is called block ID. For the same mining blocks, I have another file which is called the reserve file, and that reserve file also has got one very important field which is called block ID. So with this information, the software knows the connection between these two different information. One of them is mining block and the other one is the reserve related to each mining block. Look at this screen. Whenever I click any of this block, I can see what is the total tonnage and average grade in that block. Obviously, if I select much more than one block, I can see the summary report of selected blocks. For example, in here, the total tonnage belongs to these two selected blocks. But how can we come to this part? As I said, in our old Studio 3 Pro, we didn't have a very direct functionality, although that all the functionality was in the software. But Pro, we didn't have any kind of a one-click job, so a user can just, go through a standard process. In ISCS version 2, we basically we follow a process flow, and after this process we can create these two files that are essential for scheduling. As you see, in the first step we import the pit strings, or we can import the wireframe of the pits. In each pit you can have different pushbacks. We can call them phase. Either you can import the string and then create the wireframe, or you can directly import the wireframe of each pushback. After we import the wireframes, the next step is to cut or trim the wireframe of each pushback with the topography. And basically we are going to create a solid, incremental solid for each pushback. The next step is to split each pushback within each bench. And in each bench, what we are doing is providing some cutter strings and then cut this wireframe and convert this pushback bench in a small units. As I said, we call it mining blocks. The next step is to create dependencies, and after we create the dependencies, the next job is just to evaluate the reserve in each unit. We basically follow the same process flow in Studio OP. If I open another project, in this project, as you see, we are trying to create these mining blocks. Probably if I show you the final result, it should look something like that. We have 3 different pushbacks. Different color in here shows different pushbacks. For example, the color blue shows the first pushback. Pushback number 2 is in green color, and the pushback number 3 is red color. And as you see, I have created mining blocks for each bench of each pushback. Now, I'm trying to do the same job with this software. In the version 2 of Studio OP, we have a ribbon which is called reserve. And with this reserve, we can provide this information, create these mining blocks and the reserve file related to these mining blocks. As you probably notice, in version 2 of Studio OP, we have introduced a window which is called Task. Task window is a parallel window to your main window, which is called 3D window. Why we have introduced Task window? The main reason is in most of the cases, a user doesn't want to touch the main job. They want to parallelly create, for example, mining blocks or change the mining blocks and then come back to the main window and continue the work. So basically, as soon as you go to reserve ribbon, we are working on the task window. In the task window, as I said, we follow a workflow from left to right. First of all, we introduce the pit number and any topography. We input any block model. This block model is used for calculation of the reserve for each mining unit or mining blocks. We define the benches, and I explained why we introduce these benches. The next step is create the wireframe or import the wireframe of each pit or pushback, and then create a solid of each pushback create a solid of each bench of each pushback, and then create some mining units and then evaluate the mining blocks. There are some other steps in here which I'll explain later on. But let's start from the beginning. From left to right, as I said, we follow the process. The first step is manage. In manage, we are providing the name of the pit. If you are working in one single pit, you just introduce one pit. But if you are working in multi-pit mine, then you can choose more pits. For each pit, we need to import the wireframe of the topography. This topography, if you're working a greenfield, is an initial topo, but most of the time when we are working in a mid-term to short-term scheduling, this topography is actually the mine topo, for example, at the end of April 2017. You just need to import or add a wireframe and then assign that wireframe to that pit. The next step is to define the model. In this version of the software, you have full flexibility to always switch between one model to the other. This model is used for reserve calculation of mining blocks. The block model can be exported block model, a block model which is output block model from MPV scheduler or any optimization software, or it can be your geological block model. When I add that block model to my design, the next step is to assign each field to a relative item. For example, in my block model, I have density, I assign it to density, rock code to category, and different production field to grades, and so on. Some of the fields in here are essential. For example, category. For all users, if you remember, when we calculated the mining reserve for mining blocks, in the result file, we had a field which was called category. I can probably show you in here. In the other project, the category is basically a category which is used for mining engineers. It can be similar to categories used by geologists, but normally it's something that is defined by your requirement in your mining operation. Anyway, this is something that you have to assign, and also if you have selected a block model which is coming from an optimization software, you can also assign that field to your scheduling sequence. I will show you later on that the software is going to read this information if it's available. Again, it's optional. You don't have to always use an output block model from optimization, but the best practice is basically use those files. After we import or add these block models to our project, the next step is to fix that block model. As you probably know, for users that use our studio for a long time, they know that when we want to calculate the reserve, we need to make sure our grade fields doesn't have any dash or absent value. With fix, software basically fix those problems, or if you have any negative value, is basically to convert all this negative value and absent value to 0. After you fix your block model, I can always switch between one to the other block model. After you fix your block model, you need to go to the next step, which is define benches. Why we are doing that? The define benches at the moment due for the scheduling is helping us to switch between one bench to the other. So is a function that helps us for visualization. But most importantly, basically in the next step, software knows this is the bench elevation, and based on that elevation, the software is going to create a disk from each bench of each pushback. You can create a pit or bench definition with a fixed height, or if you're working in a project with variable bench height, then you can change the bench height. You have different way of setting up this bench height. Either you can set up manually in this window, or if you want, you can import it from a block model. If you have already design a pit with different bench heights, you can import the string, and software is going to read the information and then relate to your pit strings is going to create this table. And as I said in the last step, if you really want to change something manually, you can change it in this part. So this part is very important and essential part of the software. As soon as you define your benches in your bench toolbar, you see this window, this toolbar. And I'll show you later on that how we are going to use these toolbars. Anyway, after you create your bench definition, the next step is to define your wireframes. You can import your string from each pushback and then create your wireframe, or if you want, you can import directly the wireframe. The next step is to create the solid from each pushback. When you import or created the wireframe of each pushback, the next step, software is going to create a solid of each pushback. And software is very clever. For example, if you have a pushback inside another pushback, it's going to subtract pushback, for example, number 2 from pushback number 1. So you are going to have individual shells. And then let's see some pictures in here. For example, after I finish this step, I can see the pit DTM is basically showing the shape of the mine and the topography after mining pushback number 1. Or if you want to just see the solid of pushback number 1, you can easily select that pushback, or you can change, go to pushback number 2. There is another new window in Studio OP which is called Reserve Data, which is helping us to show and hide any object based on our requirements. The next step is to create the bench solids. So basically, software is create one bench solid from each pushback, and so is going to convert our pushback in small benches. Different color in here shows different benches. Probably you can see in this window that different bench is shown by different color. So basically, we have a split the solid of each pushback in a small benches. The next step is to creating the mining blocks. We have two different ways of doing that. One way is manual and the other way is automatic. When you go to manual, basically you can either import a string which is showing your grid lines, or if you want, you can digitize new cutters. For instance, in this case, if you see, I have created or digitized one string which is showing the cutting string, and in this window, one of the application of this toolbar is to switch off and create a clip of your window. For example, if I want to see a bench above this window, above this bench, I can increase the above, or if you want, you can increase the below. So at each time, you can always compare your cutting string with the top or below benches. I have the option to copy this cutting or cutter, strings to below benches, or if you want, you can copy these cutters to all benches if you wish so. There are some other options here to help user to prevent to create very small and unnecessary mining blocks. So if you want, you can create a filter in here and remove any small blocks with a certain volume or certain thickness. We have to do this job for each pushback, and then after you create the cutters, the next step is to create the mining blocks. So the first step is to create the cutters, and then the next step is create the mining blocks. Again, one of the flexibility of the software is you don't really need to create the cutters. If you want, you can directly go to the mining blocks. In this case, the software is going to create one mining block of each pushback of each each bench of each pushback. There are other automatic application or facility in here for user. For example, if I want, I can create mining blocks with certain tonnage. If I, for example, say the minimum tonnage of each pushback is 10,000 tons, then if I click on cut, the software is trying to find, mining blocks with this tonnage. So after you finish this step, then you can go to the next step, which is evaluate. But let me explain also the automatic one. In the automatic option, the software is able to create the mining blocks based on some settings. In the setting, software is looking at the time unit of your schedule. For example, in this scenario, we have 12 monthly plan, and then the next 2 years is quarter plans, and then for the next 10 years, from year number 3 to year number 10, we have annual schedule. In the next option, a user is going to define the tonnage, which is ore production or material production in each year, and then by combination of these two options, the software is able to calculate a relevant tonnage for each period of your schedule, and based on that tonnage is going to automatically find an area with that tonnage. After you create your mining blocks, the next step is to evaluate your reserve. Again, you have two options here. Either I can use the category which was defined in model, or if I want, I can use legend. Any legend, you can define it and then use that legend. But if I click on evaluate, the software is going to calculate the reserve for each pushback, and eventually I can see the similar result file that we had in ISDS in here. As you see, we have important field which is called category. In this scenario, I just use numeric numbers in here, but if you want, you can use any alphanumeric values or characters, for example, waste, high grade, low grade, and etc. And then this is basically two files are now ready to pass it to the scheduler. We have some additional functionality in here for creating the sequence in schedule functionality in Studio OP. We have two different types of the sequencing. One part is to create a physical sequence between blocks in vertical direction. Those facilities helping us to make sure we don't do any undercutting during your scheduling. However, if you want to change some of the sequence for each pushback, each bench on each pushback, then you can also use this method. In this sequence, the software can use the sequence which is coming from the block model from MPV scheduler or any optimization software, or if you want, you can change the sequence. For example, if you want to start mining of the blocks from a certain point, which is normally the ramp entry point, then you can use this or insert this coordinates for each pushback, and then software is creating the sequence and start mining from a point close to that ramp entry point to other places in that bench of that pushback. After we finish the sequence, the next step is to create the dataset. Why we are doing that? In some scenario, a user wants to create a different mining blocks with different size, and then we want to try it in the next step, which is the schedule. So after I finish the job, then I can go to create dataset, and then I can create a new dataset. For example, I can create a dataset based on manual mining block creation, and another scenario based on automatic mining block creation. And then when I go to the schedule, this is something that we didn't have before. In the schedule ribbon, in data settings, you can always switch between one dataset or to the other dataset. And this is really what we wanted to cover during this presentation. I hope that you find this presentation useful. Obviously, I know that you need to do some practice. If you have any question, then you can let me know. Thanks for your time. I request you to send me your question by email, and I try to answer to all your question as much as I can. My email address is kayvan.samadani@dataminesoftware.com. Thank you very much. Goodbye.